Okay, so today we are going to talk about, let me just put a mark. Okay, I can write till this point. Okay, got it. So what we're going to do today, first, so this is chapter 9 from your maths book, and we are doing mathematics. So my first agenda is to deal with mean. We'll try and understand median. We'll try and do mode today. Fourth, we'll talk about box and whisker plot.
Okay.
And then we'll talk about something related to data collection and interpretation. So if time permits, we will do all of this. Otherwise, we'll carry it forward.
No, we'll be fine. We'll do it quickly. I'm pretty sure.
Which one? Sorry.
We'll be able to do every single one.
Okay. So now tell me one thing in terms of, is this thing something that you would have done earlier, right? Box and
yeah.
Oh, okay. So in Indian students, they don't study anything like this. For them, this is pretty new. But since you would have done something like this, then we would be able to do it faster. So let's start with mean. How would you define mean?
It's basically the average.
Yeah. Mean is basically the average, which means sum of observations or quantities over total number of quantities that I have. Total number of quantities that I have. And this is how you do it. Summation, let's say x, I, where I goes from 1 to n divided by n quantities. Are you aware of this? No.
Yeah.
You're aware. Oh, fantastic. So this is about mean, and coming down to median. Let's define median.
It's basically the middle part of a list. So like the number of outcomes or number of inputs, whatever, over divided by 2. I don't know how you guys do it. So like imagine you have like 20 people, you divide it by 2, that's 10, and then you go on the 10th person on the list and select those. But you have those lists like 10 is less than equal to t, which is less than equal to 11, something like that. Then we have a whole list. You will try to find the cumulative frequency, something like that.
Okay.
And then you do interpolation.
So you're almost there, but there's one thing that you are missing, and let's try and understand that. So when you say median, basically you are talking about the middle value in your data set, right? Like you said, if I have 20 people, I'll divide by 2, and I'm talking about the 10th person, or I'm interested in the 10th person. But this is slightly incomplete. This is not what median is. So let's complete this understanding. Median is, number one, in an arranged data set. The data set needs to be arranged.
Arranged, yeah.
Yeah, so either ascending or descending, whichever order you follow, but it has to be an arranged data set. And in that arranged data set, I am talking about the middlemost value. But here is a small catch. Let's say I have odd number of data in my set, observations in my set. So let's say those data points are, let's say 2, 4, 8, 12, 13, 20, and 25. Now, if you see, these data values are already arranged in ascending order from left to right, right? So this part is already done. It is arranged. If not given as arranged, please arrange them. And then I go to the middlemost value. So I have 1, 2, 3, 4, 5, 6, 7. Now, if I'm talking about 7 values, this is an odd number. So if observations are 7, 7 divided by 2 is 3.5. So you take the next integer, which would mean the fourth value. This is the median of given data set.
Okay.
Let me know if you want me to repeat.
No, I got it.
Now, but the catch is, if you have even number of data points, then again you will do it, put it in an arranged manner. Let's say the values are 2, 4, 8, 12, 13, 20, 25, and 28. So you have 8 values now. This is not odd, this is even. So if you have 8 values, the rule for median says, and let me use this space out here, the rule for median says, take the n by 2h value and n by 2 plus 1h value and find the simple average of these two values. That will be your median. So I have 8 data points. 1, 2, 3, 4, 5, 6, 7, 8. 8 data points. So 8 by 2. I should take the fourth value. I should take the 4 plus 1, fifth value, and find their average. So the fourth value is 1, 2, 3, 4. Fifth value is this. 12 plus 13 is 25, and their average is 12.5. So median is 12.5 for this given data set.
Yeah.
So this is median. So we have done mean, we have talked about median. Okay?
Yeah.
Any doubt here?
No.
How about mode?
It's
Anything
basically the most number of, like the number which is repeated more than, which is repeated the most, basically.
Yes, the most frequently occurring value is mode. The one which is repeated most, like you said. In SAT, generally we'll have unimodal data set, which means in a given data set, you'll have only one mode. But a data set theoretically and practically as well can have more than one mode. It can be a bimodal or a trimodal data set where you have 2 or 3 values which are repeating the most. But for SAT purpose, we only will have unimodal data set. So let's say there's another value 13 out here. So in this given data set, 13 is most frequently occurring. Answer for mode would be 13. Okay?
Yeah.
Okay. So I'll erase all of this. And go back. So mean, median, mode is done. Let me come down to box and whisker plot. So, can you define percentile for me? Percentile. How would you define this?
Yeah, I'm not really sure about that topic too, but like I have learned it, but I never got a question on that. On that.
Never mind.
Like the 10%, 20%. So basically, like divided by 0. Divided by 100, and then multiply by the number of things you have.
Yes. Yes. So I'll put it very simply. Percentile means, let's say I have got some quantity. Let's say this is the total quantity of things. Total number of students taking part in SAT May, SAT June, total number of people writing IIT JEE exam. Let's say this is that total I have. The concept of percentile says that in this total thing, what you're doing is you divide it into 100 equal parts. 100 equal parts. Let's say these are 100 equal parts, where each part represents 1% of the data. So I've got something. What I've done is, let's say this is first, second, third, and similarly this is the 100th part. I've divided this entire population, if I can say, into 100 equal parts, where each part contains 1% of the population. So if there are, let's say, 1 million, followed by 60, let's say there are 1 million test takers. So if there are 1 million test takers, if I say 1%, it would mean 10,000. So each part has 10,000 participants. I've divided into 100 equal parts. So this is the concept of percentile, where given thing is divided into 100 parts, where each part contains 1% of the data. Okay. Now, box and whisker plot is a concept that is based on quartile. And which is now similar to percentile. Quartile means I'll divide something into 4 equal parts. So if this is my entire stuff, and these are 4 equal parts, let's assume them to be 4 equal parts, where each part represents 25% of the data, 25% of the data, 25% of the data. So each quartile is of 25%. Where entire stuff is 100%, it contains the entire population. Each part is of equal length, they are all similar, and they contain 25% of it.
Okay.
So this is quartile. So if you come to box and whisker plot, it's a special way, or I should say it's a tool of representing data in a particular fashion. What you have done is, you have got a box, and this box is an horizontal box. Box has whisker on both sides. And there's a number line which goes just beside or below the box. This part is called Q3. I'll just tell you what Q3 is. This edge is Q1, quartile 1 and quartile 3. There would be a line inside the box.
At the median?
Yes, absolutely right. This line may be at center. This line may not be at the center of the box, but this line means median. Median. Now, if you look at this, let's say we are talking about, again, that example where we were discussing something yesterday, Imperial College, London. Let's say we are talking about SAT, hypothetical example, SAT marks. So SAT score, let's say this is 1580. This edge on number line is somewhere around 1520. The median is, let's say, 1540. This edge is at 1400. And this edge out here is, let's say, 1280. Now, what does this mean? This basically means that this is the top quartile. This part is the top quartile, where 25%, if this is the plot of all the admits at ICL and their SAT score. So the top quartile here means that 25% of the applicants or people who got admission with ICL, their scores were 1520 or more. 25% of the applicants had their score of 1520 or more at ICL. This is the next 25%. Between 1450 to 1520, they were the next 25% applicant. This is the balance 25%. So the third 25% had their score between 1400 to 1450, and this is the bottom 25% who got admitted. Their scores range between 1280 to 1400. So hence, this is the entire plot. This is Q1, quartile 1. There's nothing called as quartile 2. It is basically median and quartile 3. Right? Now, can I ask you some questions based on the given? So if I ask you, what is the average SAT score of admitted students at ICL from the data given? What is the average score?
1450.
Okay, I'll repeat the question. Listen to me carefully. What is the average score of students getting admission into ICL? Average score. 1450?
The average
Average.
isn't it 1450?
Okay, I'll change my question. What is the median score? Median score for students getting admission into ICL?
Median is 1450, right?
Right. I'll change. I'll come back to my previous question. What is the average score of students getting admission into ICL? Is it 1450?
Yeah.
You're telling me that median is equal to average? That's what you're telling me?
I mean, like the median is, the average is mean.
Average is mean. So mean is equal to
Yeah.
median?
No.
No. So how can you have same answer for both the questions?
Oh, that's true. That's true. Yeah.
Yeah.
That's true.
So I'm asking you, what is the mean score for students getting into ICL?
Is it the quartile range?
Oh, sorry, come again?
Like, is it the interquartile range?
No. Okay, then we go to interquartile range. What do you mean by interquartile range? This is defined by Q3 minus Q1, quartile 3 minus quartile 1. So in this case, it would be 1520 minus 1400. This would be 80. So IQR is Q3 minus Q1. Quartile 3 minus quartile 1. Quartile 3 is 1520. Quartile 1 is 1400. Difference between them is of 80. So IQR is 80. Right?
Yeah.
Mean answer for this is cannot be determined. From box and whisker plot, you will not be able to give me the mean score because this data is insufficient. To find mean rate, I need two things. To find mean, I need two things. I need sum of all the quantities upon number of quantities.
But like, can we say median is kind of equal to mean?
No,
It's like the values are sometimes similar or sometimes close to.
Yes, under a special case, yes, mean would be equal to median. I don't deny that. But that's not the general rule. Mean and median are different things. So if I have to find mean, I must know sum of quantities. I can tell you that there were 100 students. So you know that total is 100. But what is the sum of scores of these 100 people? I don't know. Yeah. I know there are 50% people above 1450. I know that 50% of students are below 1450. But what are their individual scores? So I can get the numerator. I don't know that. So from box and whisker,
makes sense, yeah.
Yeah, mean cannot be determined. Data is insufficient. Insufficient. I need more information if you want me to find mean. But median, yes. Directly by looking at the box and whisker plot, this line will actually give me median.
Okay.
It may so happen in exam that they may not tell you that this is Q3, this is median, and this is Q1. You must understand that the rightmost edge is Q3, leftmost edge is Q1. This is the lowest whisker, this is the upper whisker. Okay? So such plot is also called as 5-point summary. This is another name for box and whisker plot. 5-point summary. And they will give you min, they will give you max, they will give you median, they will give you Q1 and Q3. 5-point summary. The min part, the Q1 quartile 1, the median middlemost value Q3, quartile 3, and max. So this is also called as 5-point summary. Okay?
Okay.
let's play a small game. You have to tell me true or false. I'll make some statements looking into this data. You will have to tell me whether this is true or false. At least 25% of the admitted students had a score of less than 1400. I'll repeat, at least 25% of the admitted students had the score of 1400, less than 1400. At least 25% of the students had a score of 1400 or less.
What should I say?
Sorry?
What should I say?
So you'll have to tell me whether the given statement is true or false.
At least 25% admitted students had a score less than 1400.
Yes.
Isn't that true? I mean, no, never mind, because the range is 25%.
So at least 25% of the students, that is at least minimum. There are minimum 25% of students who would have got a score of 1400 or less. I think
so. Basically, everything below lower quarter.
True. Yes.
Okay. Okay.
But I think the at least is creating a lot of confusion. This is at most. Maximum 25% students would get a score of less than 1400, not at least.
Okay.
Okay. Now, I'll ask you another question.
Go on.
25% of students have a score of more than 1520. 25% of students have a score of more than 1520. Would you agree to this statement?
Yeah.
Yes, we'll agree. 25% of students have a score of more than 1520. Okay. 50% of students get a score less than 1450. 50% of students get a score of less than 1450 at ICL.
It's going to be way less than, right?
Yes, less than.
Less than lower quartile and less than median together.
At least
50%, right?
50% of students have a score of less than 1450. Is that true? 50% students getting a score less than 1450?
Yeah.
That's true. 50% of students getting a score more than 1450. Is that true?
Yeah, 50%, yeah.
Yes, both these statements are true. 50% below this data, 15% above this value, 50%. So you will face such problems on SAT paper also, and they would be of simple nature. If you're very lucky, you should get one problem. They're very inconsistent. At times they would come, at times it's totally absent. So one problem on and off you may get on box and discuss. So now what I'm suggesting is, let's go and solve some problem on mean, median, mode, and box and whisker plot. Then we'll come down to survey and data collection methods. That sounds good.
The survey and data collection is basically the list, right?
Is basically
the list. So like you have a range and then you have the frequency, then you have to find the cumulative frequency.
So this is all about data collection here. Would mean mostly types of experiments, observations, surveys, confidence level, margin of error, and interpretation of research reports, survey results. It means that.
Okay.
So let's solve some problems on mean, median, mode, and then we'll go to data collection. So I'll share some problems, or you can also look into your book. So this is, I would want you to solve question number 2. Chapter 9, question number 2.
Okay, let me just open it up.
You want me to share the screen or I don't know if it is
It's
visible?
okay, it's okay.
Okay.
Can I use the restroom for a second?
What should I do? Sorry.
Can I use the restroom for a second?
Yes, yes, please go ahead.
Thank you.
Question number 2, exercise 9.1.
Okay. Is it option A?
Option A is absolutely correct. Perfect. Do you want to discuss this or we can move? Is there a doubt?
I was gonna choose option where's the option? Option B, but then I chose
Okay.
option A.
Let's see. So I don't know what's your method, but let's try option B. This is option B, where P stands for number of pencils, K stands for number of classes,
Student.
N stands for number of students per class, each class. So now if you see, the question says, how many pencils are there for each student? How many pencils are there for each student? So for sure, denominator contain students. Option B has pencil in denominator. So answer B or option B for sure is not the answer. P has to be in numerator. Possible answer A, C, D. So B will not be an answer. But if you look at C, C is number of classes into pencil. D is number of students into pencil divided by classes. Whereas A is most appropriate, where you have number of pencils divided by number of classes into number of students per class. So you have total number of students and you have total number of pencils. So whatever you will get number of pencils per student, each student. Hence A.
Okay.
The next question that I want to solve is question number 5. Consider integers and not real numbers.
Okay.
You need help? Shall we do this together?
I know the option, the I is correct. 7 is correct. I'm just checking if other numbers are correct or not.
Yeah, that's the right way. Go ahead.
The only option A is option A.
Okay, let's see. So before I mean getting to the answer, I'll be more interested in your approach. I'll read the question. Consider integers and not real numbers. They are the least and greatest number in a list of 7 real numbers are 2 and 20 respectively. The median of the list is 6. Number 3 occurs most. Which of the following could be average, which means possibility of the numbers in the list? Roman 1 says 7, Roman 2 says 8.5, Roman 3 says 10, and then there are 4 options. So if you can help me, how did you solve this? I'll do it on board. You go slow and tell me. I'll try and reproduce it.
I wrote the minimum and maximum.
Okay, so what should I do? Should I put them horizontally? I put them vertically.
Anything.
Okay, so let's say I'm arranging 7 numbers 1, 2, 3, 4, 5, 6, and 7. So it's given that the minimum number is 2 and the maximum number is 20. Right? This is what you mean? Have I got it right?
Yeah.
Okay, go ahead.
Then after that, I put 6 at the 4th place. And then I added 3 at 2 and 3.
Absolutely right. Yeah, fantastic. Because 3 is occurring most, and because we are going it in, let's say, ascending order, so 3 can only come here, and these 2 places, they'll be occupied by 3. Correct. What else?
No, it depends on those 2 numbers.
Absolutely. So let me call it for simplicity's sake, something like M and N. Let's say the numbers are M and N.
Yeah.
Okay. So let's see. Let's do a check. 2 least, 20 is the most. 4th place would give me median. So you've got a 6 here. 3 is occurring most, but we know it cannot occur more than twice. And because it is twice, no other number would come as twice. M and N are not equal for sure, because if they
Can I change my option?
Sorry?
Can I change my option?
Yes, you can. Tell me.
Can I make it C?
C, 1 and 3 only? Roman 1 and Roman 3 possible, right? That's what you're saying.
Yeah. Yeah.
That's absolutely correct. Yes.
That's right. Okay.
Yeah, that's right. So
I just chose big numbers and I was like, I'm getting above 10.
Yes. So what were those two numbers for getting 10? 10 is average.
I didn't get 10. I got 11 point something. But like I was getting, if I'm getting 11, if I took 19 and 18. So if I lower the numbers by like few digits, it might give me 10.
So let me only do it for 10. Let me say that 10 is a possible average. If 10 is possible average, then the formula becomes average is equal to sum of these numbers divided by 7.
Yeah.
So which means sum of these numbers would be equal to 70. And if that is the case, then 2 plus 3, 5 plus 3, 8 plus 6, 14, 14 plus 20, 34 plus m plus n is equal to 70.
Yeah.
Or I can say m plus n is equal to 36.
Yeah. That gives you an integer.
Yes, and m and n should be, so m and n are also integers. Sum of integers should give me integers. Now m cannot be equal to n because 3 is the most occurring. So there cannot be 18, 18 each. The other possibility is one is 19 and the other is 17.
Yeah.
Which means that 10 is a possible average.
It makes sense. Yeah.
So if you look at 8.5, you will see when we test this with 8.5, there will be decimal. Some would be in some decimal. Now, when you are adding integers, you cannot get a decimal. Hence, 8.5 is not possible.
Yeah, makes sense.
Yeah, so answer is option C. You got it right. Okay, the next problem that I want you to solve is question number. How is this problem? 9th is okay. Yeah, this is a beautiful problem. Question number 16, 1-6. A figure skater. Okay. What is the lowest score she can get from the remaining 2 judges if she still wants to finish first? What is the lowest score she can get from the remaining 2 judges? I think it should say what is the lowest score she can get from one of the remaining 2 judges if she still wants to finish first. What is the lowest score she can get from one of the remaining 2 judges? Now 2 judges they have not given their score. So the minimum score that she can get from any of the two judge, so that she finishes first. She still finishes first. And to finish first, she must get a composite score of a mean of 5.8 on a scale of 6. So this is application of mean.
Oh, wait, I got it now, I think.
Okay.
I know what I just got what I was doing wrong.
Mm-hmm.
Mhm. Is it 5.9? Okay.
Bingo. Absolutely right. Fantastic.
That's
How?
right.
Yeah, that's right. Please explain me how. Yes, absolutely.
Oh
Right.
my God. I was like, that's too high for the lowest number. Okay. I just did this. 5.8 equals 5.5 plus m plus n over 6.
Okay, let me write this down. So 5.5 plus, let's say, m plus n
All over 6 equals 5.8. So all over 3, yeah.
is equals 5.8. Okay, okay. Now let's solve this.
So m plus n equals 11.9.
Okay, I'll go slow. So this is
Okay.
25, 25, 8 is the 24, 24, 27.4. M plus n is equal to, I got it this way. Yes, yes.
Wait, it's 17.4.
17.4. So 5.5, if I subtract, I have 12, 11.9.
Yeah.
Okay. What next?
Then I just use the options.
Okay, now let me go without options. You're right, so you can go by options, but let's say I have to minimize one judge, and let's say that judge is n. So if I have to minimize this score, and some of these two is a constant, let me maximize m. The maximum possible score for judge m would be 6.
Yeah.
Because this is the maximum score this person can give, now the balance score should come from n such that it becomes 11.9, which means n should be 5.9. Any score less than 5.9 will not make my sum as 11.9 and will not make average 5.8, and that means she is not going to win whatever competition she's facing right now. So what
Okay.
I've maximized m so that if this is maximum, I'm minimizing n because their sum is constant. So in mathematics, if sum of two quantities is constant, and let's say both are integers or decimal, whatever it is, if I have to minimize one, I should maximize the other.
Okay.
So I've applied that rule where, let's say, judge gives maximum 6, minimum point that n can give is 5.9.
Yeah.
Okay. So this was a good problem. Something related to this, we are solving another question. I'll just find out. There's another problem which is very similar to this one. I think it's 17th, is it? Yes, 17th question. 1-7.
The average rating was 75.
Yes.
Is it 75 or 7.5?
75
Okay.
on a scale of 100.
Wait, is it out? Wait, I don't get this. It says in the first 10 ratings, the score received a rating of 75.
Average.
Okay.
The first 10
Makes
ratings
sense.
score received, average of rating was 75.
Okay, makes sense. What is the
And there are total 20 ratings happening. You have to find minimum value of 11th rating. If overall average should be at least 85.
Oh my God. It's the same question, but with more numbers. I'm not sure.
Done?
I'm not getting it.
Okay, let's do this together. So this says an online store receives customer satisfaction rating between 0 and 100, both inclusive. In first 10 rating, the store received the average of, oh, there's something missing. In the first 10 ratings, the store received, yes. So the average of rating was 75. So from first 10 ratings, the average was 75. This is the average. What is the least value? Least value for 11th rating, given that overall average for first 20 rating, it was 85. Okay, let's solve this. So if average score is 75 from first 10 ratings, and each rating could be between 0 to 100, can I say sum of first 10 ratings, scores from first 10 rating should be 750?
Yeah.
Because I have mean as 75 from 10 ratings. So some of these ratings should be 750.
Yeah.
It also says that my overall average or mean should be 85 from 20 ratings. So my overall sum should be 20 into 85, 1700. Are you with me on this?
Wait, how did you get 1700?
So the question says that overall average should be 85 from first 20 ratings. So if overall average is 85 and number of observations, so 20 into 85, sum of ratings from first 20 ratings should be 1700.
Yeah.
Of these 1700, 750 is already home. I've got 750 points from first 10. Which means now 950 points, which are the balance points, should come from rating number 11 to rating number 20.
Yeah.
Okay. Now the question says, I have to minimize 11th rating. What is the minimum possible score from this 11th rating, right?
Mhm.
In that case, let me maximize all other ratings from 12th to 20th. So maximum score for any rating is 100. And there are 9 such ratings from 12 to 20. So they will give me 100 into 9 ratings. So I'll get 900 points from 12th to 8th rating. I need 950. The balance should come from the 11th rating. So the minimum possible value from 11th rating is 50.
Yeah, I did it differently when you were talking.
Okay. So you got this?
Yeah, I just got it, but yeah, I think so. I got it. Yeah.
So should I stay on this? Do you want to absorb
Wait,
this?
wait, should I tell you the way I did it? Can you tell me if it's well or not?
Go ahead.
Yeah, I just did this. I did 750 plus 100 times 9, all divided by 200, all divided by 20.
Hold. I'll write the equation here. So you did 750 plus 100 times 9
Yeah, divided by 20.
divided by 20.
Yeah, and then the answer I got was 18.2. So I did 85 minus 18.82.5. I got 2.5.
What here was 82.5.
Yeah.
Okay. And then you subtracted this from 85.
Yeah.
So the difference
And I got
was
2.5.
Okay.
And then wait, it's not negative 2.5. And then I just multiplied that by 20.
Okay. And you got 50.
Yeah.
See, let me tell you, if you can justify and make me explain why did you multiply it by 20, this is right. Whatever you did, Ray, this is absolutely, but you will have to explain me this step. This is correct, but I want to understand your reasoning. Why did you multiply 2.5 by 20?
Because I didn't add the like I did 750 plus 100 times 9. So I didn't add the n, the 11th number. That's why.
Correct. Because factually, this is not 20, this is 19. If you understand. This is 19 because these are 19 values and you have divided by 20. So, you know what you have done is you have calculated the deficit. The deficit is of 2.5 and this deficit should come from these 20 values now. Because had 11% also given you 82.5, there's no problem, average would be 82.5. But you want to reach 85, the deficit is 2.5, this must come from all of these 20 people. It's like, these 20 people, they go on a picnic and the cost per head would be 85. So you calculated that cost per head is 82.5, whereas it should be 85. Deficit is 2.5. It should be distributed for all these people. So 2.5 into 20, answer would be 50. This is correct.
Okay. Yeah. Okay.
Okay. So we go to next problem. 6th is easy. 12th problem. 12th question. Number 12.
Going backwards.
Yeah, we are going backwards. This is 12th.
Is it A?
Question number 16th answer is D. Or is it A?
Say,
Wait.
question 12.
12. Let's see this. A. Let's check. So it says the score on Tuesday's history test for 16 students are shown in table above. Sam, who was the only student absent on Tuesday, so 16, okay, will take test next week, okay. Sam receives a score of 95 on the test. What will be median of the test? Now, if Sam's score is included, total we'll have 17 people ready. If we have 17 people, that means 17 divided by 2, 8.5. Next integer is 9. Ninth value will give me median. Do you agree?
Yeah.
Now, if that is the case, let's go for the ninth value. Interestingly,
Yeah.
data is already arranged in the table. Data is already arranged. Isn't it?
It only arrange the number of students.
No, it's not about number of students. It's about what scores they are getting. Data point is what scores they are getting. So I have somebody who have got 100 score. Then there are two people with 95 score. This is how I'm arranging the data, right? And now Sam has also got 95. So first, second, third, fourth. Then there are four people getting 90. So I've reached the 8th value. Are you with me on this?
Okay. Yeah, makes sense now.
Now the 9th value. What is the 9th value?
85.
So this becomes your median. I have an extra 95 because this is Sam.
Makes sense. Okay.
Because there were only 295. Now when Sam wrote the test, I get an extra 95. So you'll see the 9th value becomes 85. So the median score for this class is the middle value, which is the 9th value, which is 85.
Okay.
So this is a beautiful application of this simple concept called median. And that's why SAT is so interesting. Let's solve a similar problem. You're thinking this is done. You want me to do some other method? Should I use some other method? But I thought this is simple.
Yeah, this is.
Okay. So let's do one more problem, which is similar to this. And I guess it is a little bit challenging. Question number 13, next problem, 1-3. Similar concept. The only difference being you have to find except value that is not possible among the 4 options. If the median noon temperature is 40, then noon temperature for city D could be any of the following except let me know. We'll start whenever you're ready.
The option D.
Option D, which is 42 degrees. Yes, absolutely right.
Is it?
Yeah,
Okay.
that's correct.
I don't know how to
So how did you arrive at 42?
guess. Guessed it.
Okay, let's see. So can we do
It was
without?
above. It was above the median. That's why.
It was above the median. Okay, so that means you must have concluded that any value above median should be the answer.
Yeah,
Oh,
basically.
so you saw that there are 3 values below median, and this is one outlier which is above median, so that should be the answer. Otherwise, let's do. So how many cities are there? There are 7 cities.
7 cities. Yeah.
Now let me arrange them in order. So forget T right now. If there are 7 cities, then if I arrange them, the 4th city, let's say ascending order, the 4th city would give me median temperature. Am I correct? Okay. So the lowest temperature is C, I'll call it city number 1. Then I have B, which will be city number 2. Then I'll have 3, I don't know which one, but this is for sure city number 4. Do you agree? Because this is the median. So now if this is for E, F and A, they cannot be 3 because they are above 40. 68, 44, 50. For sure, this is the city which is number 3. Which means, like you said, T should be less than 40.
Yeah.
You can take any value, 29, 35, 39, whatever you want, but it cannot take a value greater than 40, which you also said. Yeah, you are absolutely right. So answer is 42. 42 is not possible for me.
Okay, you know what? I'm really good at guessing.
You're good at guessing. And I hope this luck continues when you're taking your SAT.
Yeah.
Okay. Let's go to the. So, do you have access to challenge problems on your book? So, I'm talking about particular challenge problem. Hold on, which one is this?
Yeah, I do. I do.
This is telephone lines, number of telephone lines, SAT challenge problem 1.
Yeah, number of telephone lines.
Yes, so this is here you have to punch in your answer. So I would want to see that. So kindly put your answer in the chat box.
Okay, okay.
What is the
I don't know
median
this
number of
word.
telephones? Yes, go ahead. A minute time. Take a minute.
How would I find the median in this?
Okay. So for this, I need to do a little bit of screen sharing. So can you see this problem on the screen right now?
Yeah,
Is it?
yeah.
Okay. So if you look into this, let me remove the spotlight. Okay. So it says number of telephone lines in each country in Central America and Caribbean is shown above in the dot plot. Number of telephone lines in each country has been rounded to nearest 250,000. According to dot plot, what is the median number of telephone lines? So before I find out what is the median number of telephone lines, I must find how many entries do I have in my data set. So what is the total number of countries do I have? How many countries are there in total? So each dot represents a country, right? For example, this country, how many telephone lines does this country possess?
0.
0 telephone lines. And this country out here, this has 1,250,000 number of lines, right?
Yeah.
So going by this logic, how many countries are there? How do I find that? Because to find median, I
Just
must
count the dots, right?
Yes, absolutely right. So how many dots are there? I've got
There's gonna be 16 plus 5. Wait, we switched.
Just hold on.
28.
16 plus 5, 21 plus 1, 22, 22 plus 2, 23 plus 2, 25 plus 1, 26 plus 1, 27. There are 27 countries. Now, if there are 27 countries, the 14th country in my list, they are already arranged 0, 250, 500, 750, 1000, 1250, 1750. So they are already arranged. The 14th country in my list will give me median number because there are total 27 countries.
Wait, there are 28 countries.
28 countries. So if there are 28 countries, then the 14th country and the 15th country's average will give me my median number.
Yeah.
Let's look at country at 14th number. So I can safely say that this is the country at 14th number. The average number of telephone lines out here is 0. Value for country at 15 number is 0. Average for 2 zeros is also 0. So median number is 0. Answer is a single digit 0. Tell me if it is making sense.
It does. Makes sense.
Right? So this is one simple challenge problem. Should we go for a 5 minutes break, Ray?
Sure.
Okay, so let's take a 5 minutes water break and we come back at okay, our watches differ, so we come back in 5 minutes.
Yeah.
Thank you. Need help?
Wait, after dividing 12 by 2, I got 6.
Okay.
fixed number, and then median is going to be 1.
So I'll divide this question in 2 parts. One is before, and let's say other is after. Before this new students join, what you have done is you have calculated median. Right? Median. And mean.
Yeah.
Median and mean. And after this person joins, then again there is some change in median, or maybe there's some change in mean. I don't know. But before this person joins in, what is the old median?
Old median is 6.
6.
1 is the median.
Yeah, so maximum value is 3. So median would be between 0 and 3. So if you look at this, how many students were there? 3 plus 6, 9, plus 2, 11, 1, 12. 12 students are there. So median value would be 6th and 7th values average. So you have 3 students with 0. That is 3 and 6 more students with 1, which means the 6th and 7th student would have 1 sibling each. So average of 6th and 7th students value would be 1. So old median is 1, right? Whereas if you look at old mean, that's going to be 0 sibling for 3 students plus 1 sibling for 6 students plus 2 students having 2 siblings plus 1 student having 3 siblings divided by total 12 students. So this is 0 plus 6 is 6 plus 4, 10 plus 3, 13. So old mean is equal to 13 by 12, isn't it?
Yeah.
Okay. Now they say that there is a new student who comes in. There's a new student who comes in. So if a new student comes in, my total would be 13, 1, 3. And median will come from the 7th value. If you look at the 7th value, first 3 values are 0. Next 6 values are 1, which means irrespective of how many siblings this guy has, the 7th value will always be 1. Are you with me on that?
Yeah.
So the new median would be 1 anyways. The question now says, when this new fella joins in, your median becomes equal to mean. Median becomes equal to mean, which means new mean is 1. And I know that for me, total number of students come from 12 to 13. From 12, because there's a new student entering in, I'll have plus 1, total is 13. For this to be 1, numerator must be 13.
Yeah.
Old numerator was also 13, which means numerator has not increased at all. Which means this new student has 0 siblings.
Oh my God. Okay.
Yes, so you tell me, I can repeat, or if you want me to have some other method, I can do it that as well. But is it clear?
Yeah, can you repeat the last part?
I'll repeat the last part. Okay. All this is correct, right? All this is clear. 1, 13 by 1. Now, I'll calculate the new mean, and I'll say mean, new. New mean will be equal to total number of students, which would be 13, because there's a new student who would have come in.
Yeah.
Divided by the sum of all these siblings, total number of siblings. But the point is, question says, and I read it from the question, it says, later a new student joined the class, and average number of siblings per student became equal to median number of siblings per student. So if these two become equal, then your median was 1, this should be equal to 1. Now, sum divided by 13 is 1, which means the sum of siblings should be 13. This is same as the older sum, number of siblings. tell me one thing. Is this clear? How we got 13? Is this part
Yeah,
clear?
yeah, yeah. You just
Okay.
add things. Yeah.
Yeah, so we added all the sibling 0, 0, 0 thrice, 1 6 times, 2 twice, and 3 once. Right? So
Yeah.
that's all got 13, total 13 siblings. Now to get this one, numerator must also be 13 because students have increased, or there's an increase of one student in the class. So 13 by 13 will only give me 1. So if numerator is not changing, if sum is not changing, this means this new student must be bringing in 0 sibling. Because had he got
That makes sense. Yeah.
had he got 1 sibling, this would become 14. And then it will not be 1.
Yeah.
This has to be 13, which means this guy has 0 sibling.
Okay.
Okay? Okay, now we'll go to box and whisker plot, and let me make a big jump here. I want you to go to question number 35. 35.
Literally on that question.
You are on that question right now?
Yeah, I was just scrolling through the paper.
Okay, question number 35. Good. About 25% of gyms in Shanesville have more than what number of gym members? So how do you pronounce this place? Shane? How would you pronounce this place?
Shanesville.
Shanesville. Oh, okay. Shanesville. About 25% of gym have more than what number of gym members? More than.
Then the gym members. Is it option D?
Which is absolutely correct. Yes. That is correct. Option correct. More than 25% of gyms will have more than 70% of gym members. So this is that top quartile we are talking about. The top is yes, correct. Answer is correct. So I'm not getting into this. Want you to solve this then? Is it clear?
No. Yeah.
Let's solve the next problem. Question number 36. No, not 36. I think it's 37. I want you to solve question number 37 from Khan Academy. Are you aware about outlier and rules to find outliers?
Yeah.
Okay. Then go ahead. How many high outliers are there in the data set?
So don't you use that formula 1.5 plus the interquartile range times the 1.5 plus the upper quartile times the interquartile range.
Correct. No, not 1 point times the whole thing. So the upper quartile.
No, 1.5 plus
1.5 times the interquartile range.
Yeah.
Any value greater than this value is an outlier, is a outlier. Yeah. 3 is 13. plus 1.5 times.
I don't think we need that. They gave us the min and max.
Yes.
So do we need that?
Yes, we need that.
Because the minimum is 4 and the maximum is
20.
Yeah.
And they want to know how many outliers are there, basically how many albums are there, which has a higher number of value.
Okay.
Plus qualifying as an outlier. So what's value for IQR? What is your IQR?
It's going to be 4.
4. 4 into 1.5 is 6. 13 plus 6 is 19. How many albums have songs more than 19? Look into the dot plot given
20, 21, 1.
1. So there is one outlier in this data set.
Mm-hmm.
Can you also find, let's say, same data? How many low outliers are there in this data set? How do you do that?
1. No, wait, there is none.
So that is Q1 minus 1.5 into IQR. Q1 is 9. 1.5 into IQR is 6. So
Yeah,
any
3.
value less than 3, right? There is no album which has less than 3 songs.
Yeah.
So answer is none. Okay, fine. So with this, we come down to end of these 4 things. I'll come down to now data collection methods and interpretation of surveys and results. So before I do that, I'll share something with you about what is that we are planning to cover. And so in, let's say, next 20 minutes, this is what I plan to cover. We will try and cover population, sample, types of surveys, sample parameter, margin of error, confidence interval, and confidence level from SAT's perspective. So this is all very, very basic and at introductory level. Let's try and see.
Are we gonna learn those things too, like stratified sampling?
So stratified sampling or judgmental
systematic sampling, opportunity sampling.
Yes.
Are we gonna do that too?
No. So that's not
okay.
random. Yes. So that's not cluster sampling. So you're not doing all that. Okay, so what I'll do is I'll take an example and try and understand all of this concept. So let's say, Ray, that I've got an island out here, and this is a small island which has a population of 3 million. Let's say 3 million people, they live on this island. And of these 3 million, just for theory's sake, let's say 1 million are doctors. That's a huge ratio, but let's say 1 million are doctors. I want to understand what is the average number of fees charged by doctors on this island for the first time visitor. The visitor who's visiting them first time or after a long time, what is their average consultation fee? And let's say I want to do it in dollars. Now, to meet 1 million doctors would consume a lot of my energy, time, effort, and possibly humanly. This makes the task very daunting and it may not help my research. So what I do is, rather than talking to 1 million doctors, I do some random sampling. And I pick, let's say, 1,000 doctors. I pick 1,000 doctors at random on this island, and I ask them, what is your average? What is your first time fee? And I calculate an average. First time consultation fee. Now, if you look into this thing is called as population. This 1,000 is called as sample. Now, in SAT, the scope is not defined for finding out the sample size, but in statistics, there is a formula which we apply to find what is the sample size. What should be the appropriate sample size be, so that this is representative of the population. But anyways, so this is the sample that I'm talking about. And this part out here, this is called as the sample parameter, which is under study. I'm studying these parameter or variable, and I'm trying to find an answer for this. So population, sample, and sample parameter, average first time fee, consultation fee. Let's say I do this research, and after research, my finding says that the average first time fee is, let's say, 80 USD. It's 80 US dollars for a patient who's visiting first time. That's, I don't know, high or low, but let's say this is the average fee that they charge. As a researcher, when I'm publishing that this is the fee that they charge, I know that there are some biases that may have gone. For example, doctors may not have revealed their true fee. There could be a lot of fatigue on my part by the time I was reaching, let's say, the 500 doctor, the 990th doctor, and so on. There could be some biases there. There could be some biases in picking the doctors. I may have picked doctors only from this region. I was lethargic and not to go to this region of the island. And there could be bias because of researchers' judgment in picking the sample. So to be on the safer side, I say that this is the average fee plus minus, let's say, 10 USD, $10. So this thing out here is called as margin of error, as given by the researcher. This is margin of error.
Oh, is it because you don't know if it's 90 or 70?
Absolutely.
That is, I think that is what uncertainty is.
Yes, that's what uncertainty is. So when I say this and when I publish this result, it would mean that the average fee for first-time doctors could be anywhere between 70 to 90. My research says 80, which means if Ray goes to the same island, he studies the same sample parameter as I did. He takes the same sample size. He uses the same sampling method. There's a very high chance that his average would lie between my average plus minus margin of error. Okay?
Yeah.
This particular interval is called as confidence interval. This is confidence interval. So if anybody does a similar research with the same sample parameter, same sample size on this population, there's a very high chance that his or her average would fall in this interval, which is confidence interval. Okay. Now, as a researcher, I say that my confidence level with my study, this is confidence level, not interval. As a researcher, I say that my confidence level with my study is 95%. What does this mean? This means that actually I'm making a claim and I'm saying if a similar study is done, there is 95% chance that for any other study of similar nature, the sample parameter would be between my confidence interval. I'm 95% confident that if a similar study is done, studying a similar parameter, the study's sample parameter would lie in my confidence interval between 70 to 90.
Okay.
So in SAT, they will ask you possibly something around interpretation of sample parameter, margin of error, confidence interval, and confidence level. So these are few things that you must know with respect to surveys. And one more thing that I'll tell you right now. So these are the few things that you must know in terms of interpretation. Confidence interval is the average or the sample parameter plus minus the margin of error. Confidence level is claim that a researcher makes for a similar study if done. The average or the similar sample parameter would lie in this interval. Okay. Now, one more thing. There are 3 types of study that you must know. One is called as survey. The other is called as observation. And the third one is experiment. Now, SAT says you must know meaning of each of these. Surveys, these are like where you've got a tool, and these tools are administered by a researcher or they are self-administered by the respondent. So I can ask you a question and fill the questionnaire. I can email you the questionnaire. I can distribute questionnaire inside classroom, sit out here and let people fill it. So using some tool, I am getting close-ended or open-ended responses. This is survey. I could do it in a mall, going door to door, sending emails or on WhatsApp, various methods. Observation is one where a researcher is inside a real life setting and he's observing the respondents. Respondents may or may not know about the research being done. So I could go to a retail store, take a corner spot, take a chair there, sit down, and I may be observing the behavior of customer when they are buying something or selecting something. So how are they picking the can? What are they looking at price first, or are they looking at some aroma or something else? So I'm observing and making my notes. In survey, researcher and respondents may interact, whereas in an observation, the interaction is not there. The researcher, in absence of respondents' knowledge, may be observing and making notes. Okay. Experiment is something that is interesting. So when you're doing an experiment in research, you're creating 2 kinds of groups. One is called control group, and the other one is called experiment group. Okay. The control group is the group where no intervention is applied. They are in the natural setting. No intervention is applied. Whereas in experiment, an intervention, an external stimuli is applied. You apply an intervention. So what is your class strength? The class you are in, what is the class strength today? The class that you study. In your school, the section that you study in, how many students are there?
It changes basically.
Oh, it changes from subject to subject?
Yeah.
So which subject would have highest number of students enrolled?
Maths.
Maths. And how many students would be there?
30.
30. So let's say I enter that class and randomly I divide it into 2 groups of 15 each. These 15 students, they are in their natural setting and I don't give any SAT maths training to them. But these students are given SAT training. They have been divided randomly in that class. That means they come from the same class.
Okay.
And after I have given them some training, let's say 10 hours, and here no training was done, I find about their SAT score. Let's say their SAT score out of 800 on mathematics was 680, whereas these guys, they had 740. So this is my experiment group because I applied an intervention which is SAT training. This is my control group because no intervention was applied. They were in their natural setting. And then I can conclude that SAT training helps somebody score 60 points more compared to vis-a-vis no training on SAT maths. This is an experiment that was done on 2 similar groups, divided, created randomly, intervention applied, intervention not applied. So this could be hair treatment, some hair serum, no hair serum. This could be some vitamin supplement, no vitamin supplement. This could be anything. So this kind of research is called experimental. Tell me if these some basic things are clear to you. Or you may want to ask something. Please go ahead.
Yeah. How'd you get 68 again?
Sorry?
How'd you get 68?
60.
No, 68 that you wrote, 15.
So what I said was, this is a hypothetical example. These 15 students, when I have not given any SAT, no SAT training was given, their score on math section was 680.
Okay. I cannot
So-
see 680, that's why.
Okay. So I'll write it here. 680 and 740.
Okay.
I measured the SAT score, average score. I measured this group's average SAT score, and I came to conclusion in my experiment: when you give SAT training, the score improves by 60 points.
Okay. Makes sense.
Okay. So, having done this, how much time do I have? Let me just check.
15, 13.
Oh, so I have what, 13 minutes time. Okay. So let's do some selected problems. Question number 30. A typical SAT type problem. Very much like SAT. Which of the following is an appropriate conclusion?
Every single option makes sense. Then option B.
Option B. Okay, let's see. I'll read it out first. In order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. Half of the participants were randomly assigned to receive treatment X. The other half did not receive treatment X. The resulting data showed that participants who received treatment had significantly improved eyesight as compared to those who did not. Based on the design and result of the study, which of the following is an appropriate conclusion? You said option B, right?
No, I said other than option B, everything looks similar.
Okay. So first I'll go to option B. Treatment X improves eyesight better than all others. So there is no comparison happening, right? You're only talking about treatment X.
Yeah.
Hence, B is not right. Let's come down to C. C as in cat. And allow me to share the screen so that I can mark those phrases which are disturbing phrases. Let's look at this. It says, you there?
Yeah.
Okay. C. Treatment X will improve eyesight of anyone.
Yeah, it says anyone, yeah.
So that's problem, right? Because you are talking about poor eyesight, people with poor eyesight. It's not anyone. So this is not possible, right?
Yeah.
Let's come down to D. Treatment X will cause a substantial improvement in eyesight. For who? I don't know. Let's look at A. Treatment X is likely to improve eyesight of people who have poor eyesight. This is the most appropriate conclusion. What's it? Tell me.
Makes sense. Yeah, that's correct.
Okay. So let's go to another question. I think we have 9 minutes, we can solve one more. I want you to do this one. This is SAT challenge question 3, which is about some sunflower plants. If you can locate SAT challenge question 3, sunflower plants.
No, I don't have it.
Okay.
For me, challenge question 3 is international flights.
No, so which is the sunflower one? What's the number for sunflower? There's a
I don't
graph.
have that question.
You don't
I have that. Some magazines, airplanes, and flights.
So I'm actually talking about this particular problem.
Yeah, I don't have that.
You have this problem?
No, I don't have that.
Okay. Let's do this one. Control group, experimental group.
Yeah, can I see the options?
Sure. Which conclusion is not valid?
I think it's option C.
Okay, let's see. C. What does it say? It says sunflower plant grow under lower magnetic field conditions were more likely to be taller than sunflower plant grown under normal. So this was your normal group. This was the lower magnetic field. They are more likely to be taller. Median height, yes, they are more likely to be taller. C is a valid conclusion. Right?
Yeah.
Let's look at A. Sunflower plants grow under magnetic field conditions who are more likely to weigh.
Yeah, that's the problem. Yeah.
Yes, so it's not about their weight, it's about their height. And hence answer is A. This is not valid. Right?
Yeah.
Okay. Let's go to one last problem, and you have this international flight question.
International flight in the challenge questions, right?
Yes, yes. Arriving within 15 minutes of the scheduled arrival.
Yeah, I have that. Yeah, I have that.
Let's do this one. Which of the following conclusion is best?
Is the option D?
Option D. So a random sample of international flights in 2013 showed that 79% of flight arrived within 15 minutes of the scheduled arrival time. So this becomes your sample average.
Wait.
Okay. Yes, go ahead.
79% of the flights. Oh, it's for 15. Wait, just a sec. I might change it.
Yes, yes.
Oh, it's option C.
It's option C. Yes.
It is okay. Because 95% is the confidence level.
Yes, and you don't do anything to confidence level because that is researchers' claim how confident research is. Yes.
I could have gotten this wrong.
Never mind. Let's do one last problem, which is the next one, the magazine one. In-flight calls, sorry, in-flight calls. In a poll of 1570. Is that problem there with
Okay. Yeah. In a poll of 1578.
1578. Sorry, yes.
I'm pretty sure in-flight calls are like is allowed. What? Oh, reporting a margin of error.
Equal to percentage of all American adults who would say that airlines should allow in-flight calls.
Okay. Is it 95%?
95%? You sure? Let's see. Can you see my board?
Confidence level, right?
So 44.8% in that survey said flight should be allowed, in-flight call should be allowed. This number had a margin of error of 2.5%. That means this would be at a lower end, 42.3%. At a higher level, this will be 47.3%. So this is the confidence interval. Now they say, what is the plausible number if you have to apply this research to whole of the America? What would American results, American adults say? What is the average number? Plausible, possible. Now look at the options. Let's go to the options. If you go to the options, and I'm sharing the screen, 40%. Now 40 is beyond 42.3 on the lower side. 43 is between my range. 48 is outside my range, and 95% is the confidence level. So if this survey is done on whole of America, one of the plausible possible value would be 43%. It should fall in my range. 40 is
Wait, is it
beyond.
right or wrong? I don't get this.
Okay, so I'll read the problem and we'll construct this from the
Oh,
scratch.
got it. It should be between the range. 95%. Again, I made the same mistake.
Yes, you made the same mistake. Got
Oh,
that?
I just lost 100 marks there. 100 whatever marks it is.
But never mind. I mean, it's about realization, and it's good that you are realizing that possibly you underread or overread and did not understand the question. But is it clear now?
Yeah, it makes sense now. Yeah.
So if you do it on the entire American adults, then this is one of the possible. Which of the following is most likely? This is most likely among the four options.
So wait, what type of question will they ask you for confidence level?
So confidence level, quite frankly, in my last 5 years of SAT training, I haven't seen a single question that was based on confidence level. So that is more of confusion. To create confusion, they would put it there. But otherwise, confidence level, the implication of confidence level is not under the scope. Otherwise, if you increase or decrease the confidence level, then this margin increases or decreases. So what you are asking me, I'll still try to answer that. So let's say, so this question is done, but I'm using the same data array to answer your question. If let's say if someday they decide to ask something on confidence level, what would happen?
You cannot see the board.
You cannot see the board. So I go to the board.
Yeah.
Okay. And okay. So I'm constructing a problem so that you understand the implication or the meaning of this. So let's say there's this researcher who says that if you do any other research, my confidence level is 95%. What does this mean? This means that if similar research is done, researcher is 95% confident that it would be in this range. Okay.
Yeah.
If two scenarios, if I decrease my confidence level. So when I decrease my confidence level, then I'm decreasing the confidence level. Then my margin of error would go down.
Okay.
But if I increase my confidence level, let's say 99% confidence level, 99% confidence level, then I'll have to have a higher margin of error so that something falls in this. So for a wider range, I'll be more confident that your average, any other person doing it, average will be in my range. Higher confidence level, more margin of error required.
Okay.
Lower confidence level, my margin of error can go down. Think logically. If I have to be more sure, I need a higher range. So that your average falls in this. If I am less sure, my margin of error by the same logic can go down, will go down.
Okay, now makes sense. Yeah, it makes sense. So if the confidence goes up, the margin error goes up.
Yes,
if it goes down, the
must
margin
go
error
up.
goes down.
Because if you give me more margin, I'll be more sure that some average will fall into it.
Yeah.
If you give me lesser margin, my confidence will go down in the sense that some other researchers' average would fall in this margin. You give me lesser margin, I'm less confident. You give me more margin, comparatively, I'm more confident.
Okay, makes sense. Yeah, got it.
So this was an excellent question that you asked me. So SAT people, they will never ask you to find confidence level, but yes, there's a possibility where they give you a question. What if you increase the confidence level? What happens to the margin of error? Remember, you increase the confidence level, the margin of error should also increase.
Yeah.
I'll be more confident if you give me more field to play. If you give me more scope, I'll be less confident if my scope is reduced.
Okay, makes sense.
Right. So with this, we come down to end of this chapter 9. And you should follow your timetable now. If there's any more lecture required, I think Uday will be concluding maths. But if there's any doubt and if you want any session, we can always connect. Okay. And Anubhav sir, he would be there and then he'll take a balance part of reading with you, the even sessions, and Uday will do the maths part. Okay.
Okay.
Right. Thank you so much. Bye. Take care.